This is part 11 of the series Right Triangles and Trigonometry. In this part, we're going to begin by talking about a basic application of trigonometric functions, and that is angles of elevation and angles of depression. An angle of elevation is an angle made with a horizontal and an object above. So let's say that you were standing on the ground and you were looking at the top of a building. The angle made from your line of sight horizontally, parallel with the ground, and the object above, this angle, is an angle of elevation. On the converse side, if you're standing on top of the building, an angle of depression is the angle made from your line of sight horizontally, parallel to the ground, to an object below you. So this is an angle of depression. Now, if you remember from our discussions on parallel lines and transversals, that this line and this line would be parallel because they're both horizontal. This would be a transversal, and these two angles would be alternate interior angles, which would make them congruent angles. So that's a concept that we're going to be able to use when we deal with angles of depression and angles of elevation. So again, an angle of elevation is an angle made from the horizontal to an object above. An angle of depression is an angle made from the horizontal to an object below. So let's go ahead and see if we can use this in a specific example. So here's our example, and let's go ahead and read it and see if we can absorb what it's saying. You are standing in a valley at the base of a hill, looking at your faithful dog Biff, who is standing on the hill overlooking your position. You see Biff through an angle of elevation of 32 degrees. You estimate that the horizontal distance from you to Biff is about 300 feet. Approximately how far above you is Biff standing? Now, the key to these types of problems, at least for me, is I have to draw a picture so that I can see what's going on. So let me go ahead and bring up my masterpiece of my interpretation of this situation. So here is Biff at the top of the hill, and here you are imploring Biff to come down from wherever he is, and this is the height, and here is the angle of elevation. So let's go ahead and put in our information. We know that our angle of elevation is 32 degrees. So this angle is 32 degrees. And we estimated that the horizontal distance from here to Biff is 300 feet. What we're looking for is how far above us is Biff. So we're looking for this value here. Now that means we can go ahead and employ our trigonometric functions to find this distance. So we do the same thing we normally would. We start at the angle, sum old horse, nope, can't use it, don't have the hypotenuse, caught a horse, taking oats away. It's tangent. So tangent of 32 equals taking oats away. X over 300. Multiply both sides by 300. These go away. Multiply this side by 300. And we have 300 tan 32 equals X. Now I have to solve this, and so I just put that in my calculator. In problems such as this, then, we can just go directly to the calculator because we don't really need the exact value. We're just looking for an approximation of the height. This is a more practical type of problem as opposed to a theoretical. So this is 300 tan 32. And that gives us 187.5 feet, 187.5 feet. So we say that this is approximately 187.5 feet. So he's way up there. So that's a basic angle of elevation, angle of depression type of problem. All right, let's go to the next section. In this section, we're going to talk about the areas of triangles. Now, you may think you've already covered all that can be covered with regard to area. You know that the area of a triangle is 1/2 the base times the height. But unfortunately, in a lot of cases, you're not going to be given the traditional amount of information to be able to find the area of a triangle. Up to this point, we've been always conveniently given the height or a convenient way to find the height and given the base. But there may come times, and there will come times, when you're not given that convenient information and we have to improvise. So there is a formula for area that uses trigonometric functions. So take this triangle ABC, and characteristically you will notice that in triangles the angle measure is given as a capital letter, whether it's Greek or in our English numbering system, and the side opposite is usually lowercase of that capital letter. So side A is opposite angle A, angle B is opposite side B, and angle C is opposite side C. So that's characteristically how you're going to see these things represented. Now, if we want the area of this triangle, we know that it's going to be 1/2 the base times the height. So the base in this case is B, and the height is H. But if we're not given this directly, we may have to find it. For example, if we're given this side and the base, we would have to use a trigonometric function to find that height. And so we know that this height value is some old horse. It's going to be the sine of this angle, which is equal to this height over the hypotenuse of the triangle, which is C. So sine equals H over C. And if we solve for the height, it's the side C times the sine of this angle. Therefore, the area becomes 1/2 B, which is the base here, times the height, which is C sine A. C sine A. Now, let's take the case where you know this angle and this side. In that case, then, again you have area equals 1/2 base times height. In this case now, this height value is going to be some old horse. So sine C equals H over A. Sine C equals H over A. Solving for H, A sine C equals H. So using this angle, we have a different function for our height value. And so the area in this case would be area equals 1/2 B, the base, times the height, which is going to be A times sine C. The same situation would arise if you were given two different pieces of information. So let's set that situation up. Let's say that we have this situation where you're given this side or this side, and this becomes your height value. In that case, you would either use this angle or this angle. So representing that, again, 1/2 base times height. If we were to use this angle, it would be 1/2 base. In this case, it would be A, would be the base of your triangle. You have to kind of look sideways at it, times this height. Now this height is going to be some old horse. So sine B equals H over C. Sine B is H over C. Solving for H again, we get C sine B equals H. So the area of this triangle can be described as 1/2 the base, which is A, the base, times the height, H, which we said was C sine B, C sine B. And for the last, if we were given this angle in this situation, we would have 1/2 the base. Again, it's going to be A is the base, 1/2 the base, A, and the height now becomes C. So it's sine C equals H over B, some old horse. Again, we have sine C equals H over B. Solve for H, multiply both sides by B, and you have B sine C equals H. So we replace this height, H, this height, with B sine C, B sine C. So you have 4 different formulas. Now, I would not recommend memorizing these. Just understand that to find the height of your triangle has to be based on the information you're given in the problem. If you're given enough information to find this one, that is either this side or this side and this side, and one of these two angles, then you can use one of these two. If, on the other hand, you're given either this angle or this angle, and this side or this side, then you can use one of these two formulas. So let's give this a try and see what we can come up with. In this example, we have a standard triangle here. It's not a right triangle, so we don't have any convenient ways to find the height. And they give us this side, and this angle. So I'm going to interpret the distance, the altitude from vertex B to segment AC as our height value. And so I'm going to go ahead and draw a line in there. And we're going to use that as our value. So now this is going to be our height. So let's go ahead and label this as our height value. And let's begin. Now again, I'm not going to memorize the formula, so I'm just saying that area is 1/2 base times height. In this case, my base is 28. So this is 1/2 28 times the height. Now we have to figure out what the height is. So I have this value, and I'm looking for this, and I have this side length. So some old horse. So we can say that sine 37 equals some old horse. H over 16, multiplying by 16, multiply by 16. We know that H equals 16 sine 37. So to replace that in this equation, then, we have 1/2 28 times height, which is 16 sine 37. Now that's all that's left, is for us to put this in our calculator and find the response. So let's move this guy over here. And we have 0.5, which is 1/2, times 28 times 16 sine 37. And our value is 134.8. So that's our area. Approximately 134.8. Let's go ahead and recap what we did here. We described that we had this side, and this angle. So it was obvious that this was going to be the height. And the way we find that height was going to be some old horse. So we set up the expression here, sine 37, some old horse. And then we solved for H, multiplying both sides by 16. And then we took that and substituted it into our equation for our area. So the area is 1/2 the base, which was 28, times the height, and this expression replaced the H down here, and then we just typed this into our calculator. Again, we didn't need any exact values or anything like that. We're looking for an approximation of the area to the desired precision. So let's, in the next part, go over another example.